Sorry, I'm lying. If you increase your volume, you didn't change the number of moles that was in there. Like in terms of it looks like I added more balls in there. I didn't want to. I wanted to show you that this. So if I have 2 balls in this container, but now I double my container size, I didn't increase the number of balls. I just increased the space where they can be in. Okay. So in other words, my original moles must equal my new moles. That makes sense? How do I get moles? I get moles by taking the concentration, my original concentration, times my original volume. And so my new moles must be my new concentration with my new volume. So if I dilute a diluted solution, I use this equation. And that's where it comes from. My moles stay the same, but my concentration times my volume is now different. So now if I want to work out my new concentration is taking my old concentration times my old volume divided by my new volume. And that's what I was doing here. That's what I'm doing here. I just didn't mention it all the new. Okay, so my new concentration, my concentration was given as 1,82 times my volume is 50 cubic centimeters. We don't work in cubic centimeters. How do I go from cubic centimeters to cubic decimeters? Divide by 1,000, so 50 divided by 1,000 is 0,05, divided by my new volume is given as 1 cubic decimeter. So that's just dividing with 1. So the concentration of my base is 1,8 times that. That's 0,091. Mole per cubic decimeter. Okay? That is the concentration of what I'm dripping in here. So I have that. That is 0,091. Now I want to know the amount that I used here. How many moles did I end up using? I know the concentration, how strong the concentration is, and I know how much I used. This is just how much they prepared. It's not how much they used. Does that make sense? So they did use all of it in their burette, but when they dripped it in, they only dripped in a certain amount. They tell us that the acidic solution was then titrated against the titration required 44 cubic centimeters. So in other words, the volume, the concentration is 0,091. The volume used is 0,044. And so the moles used, again, always we go from there to our 0.044. We try and find moles times 0.091 is equal to 0,004004. Okay, that's how many moles of the sodium hydroxide was used. Now, if we look at our equation, we can now see, well, what was the relationship? For every 2 moles of sodium hydroxide, 1 mole of the oxalic acid is titrated. Okay? So, what would you do with this number to know how many moles of acid was in here? If this is how much sodium hydroxide I used, and for every 2 of these I use 1 of these, how would we get how many moles of acid was there? Sorry? I don't hear you. You'll divide by 2. That makes sense. If I used 2 of these to make one of these, and I used, let's say this was a 4, it means I made 2 of this. So this one will be 0,002002. So you can just see it, or you can just substitute into this.
No, I just said I don't remember getting any of this in my exams. So
Oh.
it's quite interesting.
Is it? I can imagine. Is it charging? Not really. Okay, guys. Now this is therefore what they tell us. How many moles was in there? Up to this point, you get most of your points. So this is going to be the standard procedures that you will follow, no matter what they ask you. Okay, I can't really say that, but this is the standard procedure. Now, we haven't answered their question yet. For 10 marks, we need to do more. But up to this point, you should really all be able to get to this point. Now, I know my thing looks very messy. There's not even different colors. It's all green. So, up to this point, do you understand what I'm doing? I don't care whether you know the method. That's not important to me whether you know the method. It's important that you understand what we're doing. Sindile, how do you feel about it? Not positive.
I understood where you derived your formula from and how, but now I don't understand the zero. How do you know if it's the 0.091? How do you know if it's the top part or the bottom part?
Okay, so that's what I'm saying is I suspect the problem is you want, that's exactly, is it the top part or the bottom part? What you are seeming to misunderstand is that there is in a titration there is the known and the unknown. Now it depends, this could be an acid or a base. Okay? Now the 0,91 was what, it was a solution that the students made themselves. Okay? They took a bottle that told them the solution here, and they diluted it even more, and then they calculated, now this new solution that we have, what is the concentration in here? So is this the known or the unknown? Do I know this concentration or not? Why do you say not? I took a known concentration and I just diluted it more by dividing the volume again. So if I doubled the volume, I just say this was 2 moles per cubic decimeter now, and there's 50 moles now, I make it 100 moles, which means I've doubled the volume, so I've halved the concentration. We do know it. Well, we might not know it because we're not reading it off in this case. In this case, it's still known, even though I have to quickly calculate what the new concentration is. But if I talk about an unknown concentration, it's literally like asking how much acid is in vinegar or in a lemon. We can't take a lemon and kind of look at it. We don't know it. If I want to know it, I need to do a test on it. So I take an unknown concentration solution, and I take a known solution from my chemistry lab, or you can even in your house, if you take your drain cleaner, you can read on there, it would say 5% sodium hydroxide or lithium oxide or whatever it has inside. It will tell you it's a known solution, and even though you might dilute it, you can still just take whatever they told you that's known and divide by however much water you added to dilute it. Does that make sense? Now, I want to use this known solution to go and add to the unknown solution that I am measuring the whole time. While I'm doing that, I'm waiting until this one is neutral. So I'm measuring how much of this known one do I need to add to make this one neutral. If I know how much of this one was added to make this one neutral, then I go and look at the equation. According to this equation, for every 2 of the known one made one of these ones neutral, H2O. So I know if I used 1 mole of this, I could only titrate half of this, or half of that, half a mole. Does that make sense? So in other words, it's not knowing this concentration is for the acid or this concentration is for the base. It's knowing what is known. So in other words, the 0.91, that concentration that I worked out, I was working out the concentration of a known concentration already. So I know, and that was for the sodium hydroxide. And look what they're trying to do. They're trying to determine the amount of impurities contaminated a sample of that. So the unknown value is the acid. The known value is the sodium hydroxide. So we know that this is going to be the known value. This is the unknown value. So now that I have the known value, so are you with me a little bit more now?
Yes.
Are you sure? 100%. Nice. Okay. So I divide that by 2. Again, if it's something more complicated, you can just use this standard ratio that if you take the mole of the acid divided by the mole of the base, it must equal the coefficients in front. So in other words, in this case, the mole of the acid was 1, of the base was 2. Where do I get that? The mole of the acid was 1, of the base is 2. And then I know the mole of the base is 0,004004. And then when I multiply both sides with the 0,004004, I get the mole of the acid, which is this divided by 2. Okay. Bekan, are you okay with this? You sure? And Olivia? And Busso? Okay. You guys dare not get full marks for this thing. Okay, you don't have to get full marks. At least you have to get full marks up to this point. Okay. Now, we've not answered their question. Okay. We've done the titration. We know how many moles of acid is in here. We know the mole of acid. But what they're asking me in this question is calculate the percentage purity. Now, all I know more about this oxalic acid is I know how many grams there was to begin with. Okay? That's how many grams I started with. Now I know moles. If I have moles, I can get to concentration, or I can get to grams as well. So they give me how many grams there was. So let's just quickly see, is the amount of grams that we used equal to the amount of grams that our calculation showed us we used? So our calculation says that we used this many mole. So let's see how many, if I use this much mole of acid, how many grams of acids do I have? So if I go up, I've got N 0,002002. Okay, I want to find out the grams, and that would be taking my mole times my molar mass. So it's 0,002002, and my molar mass is this ridiculous thing, H2C2O4. So H is 1, C is 12, so it's 2 times 1, sorry. 2 times 1, because it's H2C2O4. Do you guys know where I'm getting this 2 and this from? 12 times 2 plus 16 times 4. You guys know where I get this from? Bukani? You sure? Uso? Okay, from the periodic table, the atomic mass. And so this gives me 24, this gives me 464, 24, 64 is 88 plus 2 is 90. 0,00, well, just times 90. If I times this thing by 90, I should get 0,018. 018. No, that's times by 9. 18. 018 like that. Okay. This is how many grams it told me I used. But they told me I actually started with 0,57 grams. Do you understand? Which means all of the extra grams were impurity. Does that make sense? So in other words, all I need to do, if they ask me what percentage is purity, well, it's this divided by that. Times 100%. Okay. I'm not even going to do that, but I think it was something like 27% or something like that. Can you quickly do that for me? Just divide this 0,1. I suppose I can do it. 0.18018 divided by 0.75. 24. 24,04%. Hmm? 02, sorry. Thank you. So yeah, granted this last little bit, I grant you that was an out of the ordinary question, but doing the titration is a standard. You'll find it in almost every exam. Okay, unfortunately I have to go.